real-time three-dimensional dynamic navigation system in endodontic microsurgery, a cadaver study that was published in 2022 in JOE by Sarah Aldahmash in collaboration between Maryland University and Princess Noura University. 3D dynamic navigation system is an emerging technology that aims to deliver accuracy and safety for different dental procedures. This technology has been successfully tested before for locating calcified canals, post-removal, endodontic retreatments, and also for performing intraosseous anesthesia. Recently, 3D dynamic navigation system has been explored for endodontic microsurgery with promising results. However, the literatures about this are sparse. Therefore, the aim of this study was to evaluate the accuracy and efficiency of 3D dynamic navigation system in performing endodontic microsurgery compared to the freehand techniques. 2 fresh cadavers head were brought, and a total of 48 roots were divided into 2 groups, 24 roots per each group. For the technique, in a 3D dynamic navigation system, they used the guided navigation drill and they performed the procedure looking at the monitor. For the freehand techniques, they pre-planned the surgery on CBCT and they perform it under the dental operating microscopes. For the outcome measurement and to reduce bias, they brought a board-certified radiologist that was not involved in the procedures. Then, they evaluated the virtual accuracy measures on CBT scans by superimposing the pre- and post-operative CBCTs. This evaluation was carried on in 2 dimensions and 3 dimensions, and in all parameters they compared between the planned positions and the final positions. So in 2 dimensions they compared between the platform depth deviations, which is the lateral deviations, apical depth deviations, which is deviations at the apical level, and also the angular deflections. For the 3D deviations, they compared the global platform deviations and the global apex deviations. Another evaluation was done for the osteotomy. So they compared between the height of the osteotomy, which is the greatest apicocoronal distance, and the length of the osteotomy, which is the greatest mesiodistal distance, and also for the depth of the crypt, which is the greatest facio or buccolingual distance. In addition to that, they evaluated the volume of the osteotomy by using the Mimics Innovation Suite, which is a software that is used to 3D reconstruct the defect and measure the volume in cubic millimeters. For the results, if we go to table 1, we can see the comparisons. For the 2D deviations, platform depth deviations and apical depth deviations, both of them were significantly lower in the 3D dynamic navigation system. If we go to the 3D deviations, you can see clearly now it is lower, significantly more in 3D dynamic navigation group comparing to the freehand groups. They also evaluated the time, and as you can see it on the table, they recorded the time in seconds. So if we converted it to minutes, for the osteotomy and root end resection procedures, it takes about 9 minutes for the 3D dynamic navigation group, and it takes 19 minutes for the freehand groups. The root end filling and for root end filling and root end preparation, it takes between 4 to 5 minutes, so there was no significant difference in both groups. The total operating time was 13 minutes, more or less, and 23 minutes for the freehand group. So it was significantly lower in the 3D dynamic navigation group. Table 2 is for the comparison for the osteotomy. I will not go through it all because of the time, but as we can see clearly, it was minimally less invasive in a 3D dynamic navigation group comparing to the freehand group.